So what I am saying here, you can see I have access of my real switch. Okay, and on real switch, when I am running this command, so MAC address table, there are some MAC address by default, right? These all MAC addresses are static MAC address. Then how switch have learned these MAC address dynamic entry? Because in my rack, switch is connected with another devices. Like, let me tell you about this switch, about switch 1. So switch 1 is connected with 4 router. Switch 1 is connected with 4 router, R1, R2, R3 and R4, like this. And router 1 is connected with 0/1 interface, router 2 is connected with 0/2, 0/3 and 0/4. Router 1 is connected with 0/1 port. This is R1, this is R2, this is R3, router 3, and this is R4. And this interface is 0/1 interface, 1/0/1, I think 1/0/1. So let me write 0/1 directly, 0/1. This is 0/2 interface, this is 0/3 interface, and this one is 0/4 interface. So you can see on these 4 interface, switch have learned MAC address 0/19, 0/1, 3, 2, 4. So that means these are the MAC address of routers. On fast Ethernet 0/1, it have learned the MAC address of router 1. On 0/2, it have learned the MAC address of router 2. 0/3, it have learned the MAC address of router 3, and on 0/4, it have learned the MAC address of router 4. So 4 router are connected, and 0/90 port is connected with another switch, means switch 2. Switch 1 is connected with one another switch, that is switch 2 in the rack, and the link between switch 1 and switch 2 is 0/19. 0/19. So that's why switch have learned these dynamic MAC address, these 5 dynamic MAC address, right? And these static MAC addresses are MAC address of protocols. Like by default on switch, on all switches, if you will purchase a brand new switch from the market, by default there are some protocol running, like DTP, like VTP, dynamic trunking protocol, if anyone know VTP, VLAN trunking protocol, spanning tree protocol. So for those protocols, these MAC addresses are here in the MAC address table of this switch. After that, here if I will show you, see how many total number of MAC addresses are there in the MAC address table of switch. So 25 MAC addresses are there on this switch. Okay, and then so MAC address table, and if you will put question mark, you can see you have lots of command, right? Like command to check aging time. Now first question is what is aging time? So guys, whatever MAC address which have learned on these interfaces, whatever MAC address which will learn dynamically, it will flush that entry after a specific interval of time, that is called MAC aging time. And by default MAC aging time is 300 seconds. Means after 300 seconds, this switch is going to flush these 5 entry. Okay, because these are dynamic MAC address, it have learned these 5 MAC address dynamically. Okay, so if you want to check MAC aging time, what is the aging time here? So we can run this command, so MAC address table aging time, and by default MAC aging time is 300 seconds. For VLAN 1, why for VLAN 1 only? Because for now we have only one VLAN on this switch, that is VLAN 1. Guys, as you know, switch has one broadcast domain, right? Means all ports of switch belongs to single broadcast domain. Again, we have option, we have one feature to divide broadcast domain on switch with the help of VLAN. VLAN is used to, just I am giving you one overview, not discussing the VLAN, because VLAN is a separate topic in switching. But if I will give you one overview of VLAN, so what is VLAN? Let's say here I have one switch, and this switch is connected with some computers. Like here we have one computer, 2, 3 and 4 and 5. Okay, out of these 5 computer, let's say these 2 person belongs to sales department. right? And these 3 user belongs to management department. So what we want that traffic of these user means broadcast traffic of these users should not enter in sales department, and broadcast message of sales department should not enter in management department. So what we can do on this switch, we can create 2 VLAN. Let's say I have created 2 VLAN, VLAN 10 and VLAN 20. I will put these 2 interface in VLAN 10 and these 3 interfaces in VLAN 20. Now what will happen, these 2 devices cannot communicate with these 2 devices. Why? Because now both are in different broadcast domain. So on switch also we can divide large size of broadcast domain into a smaller part of domain, right? Broadcast domain with the help of VLAN. The tool is VLAN. So by default on switch, you know why we have only one broadcast domain on a single switch? Because by default all ports of switch belongs to same VLAN, that is VLAN 1. By default all ports belongs to VLAN 1, and here manually we can configure the VLAN, we can assign the interfaces in VLAN. Okay, so that's why for all VLAN here MAC aging time is 300 seconds. Let's say here if I will configure one VLAN, let's say for I am configuring one VLAN, that is VLAN 10. VLAN 10 exit, and now if you will check again MAC aging time, so MAC aging time again you can see output is exactly same, because there is no any interfaces in VLAN 10. Still VLAN 10 is available, but for VLAN 10 we don't have any MAC aging time, because MAC aging time is time to flush the MAC address table of interface, which switch learn dynamically, which switch have learned dynamically. So until and unless you will not put any interface in VLAN 10, it will not learn any MAC address in VLAN 10. It will learn all MAC address in VLAN 1 only, because by default all ports are member of VLAN 1. We can verify it by running command show VLAN brief. By running this command we can see these are the interfaces of this switch, and all interface belongs to default VLAN, that is VLAN 1. VLAN 10 is there, I have created VLAN 10, but there is no any interface. VLAN 20 is also there, but in VLAN 20 there is no any interface, right? And after that there are some more VLAN that are default VLAN on switch. These VLAN are not used for our purpose. So here I have configured one VLAN. Now I am going to put one interface in this VLAN. Let's say interface fast Ethernet 1/0/1. This port is connected with router 1, means now router switch is going to learn MAC address of router 1 in which VLAN? In VLAN 10, because I am going to put this interface in VLAN 10. Switch port mode, switch port access VLAN 10, right? And now again I am going to check first MAC aging time. Now you can see MAC aging time for VLAN 1 is 300 and MAC aging time for VLAN 10 is 300. 1 and 10 for both MAC aging time by default is what? 300. If you want to change this MAC aging time, why we have MAC aging time? First of all, tell me this. Can anyone explain, guys, why we have MAC aging time? Why we have MAC aging time, guys? See, if let's say switch 1, this switch is connected with one another switch here, and this switch is also connected with another switch, and this switch is also connected with another switch, right? And all switches have lots of computers. Lots of computers are there. So this switch will learn MAC address of all computers on single interface, right? That means on a single interface switch can learn multiple MAC address. So maybe because of lot of MAC addresses in the MAC address table, switch cannot learn new MAC address. Let's say MAC address table of switch is full. Because see here one more thing on this switch, that is here we can run so MAC address table, and then MAC address table count. See how many dynamic MAC addresses are there? 4. In which VLAN? VLAN 1. And how many MAC addresses are there in VLAN 10? 1, right? And how many MAC addresses this switch can learn? 6000, around 6000. Means switch can learn only 6000 MAC address in their MAC address table. Let's say switch is receiving traffic of more than 6000 user. So how it is going to learn the MAC address? Now there is no space in MAC address table. So that's why whenever switch will learn dynamically any MAC address dynamically, it will flush that entry after 300 seconds. Okay. So to save the storage of MAC address table, we have this mechanism to flush the MAC address after MACaging time. But if you want to increase it, because see, whenever switch will not found any entry, let's say here router 1 MAC address is 0A, router 1 MAC address is 0A, router B MAC address is, router 2 MAC address is 0B, C, 0C and 0D. These are the MAC address of this computer. Now if switch will receive any frame on this interface, let's say source is 0A and destination is 0B. Okay, switch will receive the frame on this interface. First of all, it will update their MAC address table. After that, it will check destination. Destination is 0B. If it will not find any entry in their MAC address table, it will perform what? Broadcast. It will forward the frame to all PC. It will forward one computer router, 2 also, 3 also, 4 also. So because of that, let's say you want to increase MACaging time. So yes, you have option to change the MACaging time. Or let's say if you want to decrease the MACaging time, that you want that your switch should, keep maintaining entry for 100 minutes only. For 100 minutes only. Because there are lots of user who is not able to, or one more thing, we can use this switch as a layer 3 switch also. So let's say I need more memory for the routing purpose, I have very less memory for switching purpose. So again automatically MAC address table count will decreased, right? So it's totally depends on you. If you want to increase the time, if you will increase the time, what will happen? Flooding will increase, because switch will perform unknown unicast flooding whenever it will not found entry in their MAC address table. And if we will increase the time, yes, definitely flooding will reduce, but again we need memory. So sometime interviewer can ask you question like, switch is performing lots of unknown unicast flooding, right? We need to reduce it. So what is the solution? Solution can be increase the MACaging time. If you will increase the MACaging time, switch will not flush the entry quickly. Okay, got it? So that's why I have access real device, just to show you. See, on real devices we have multiple option, lots of option, and we can check MACaging time for a particular VLAN also. We can change the MACaging time for all VLAN also. MAC address table aging time, and then VLAN. For which VLAN you want to, what should be the MACaging time? MACaging time is, let's say, 100 seconds. And then for which VLAN? For, let's say, VLAN 10. So now for VLAN 10 only I have changed the MACaging time. For rest VLAN, MACaging time is still what? 300 seconds. For VLAN 1, because on this switch there are only 2 active VLAN. VLAN 1 and VLAN 10. For VLAN 10 MACaging time is 100 seconds. For VLAN 1 MACaging time is 300 seconds. Is it clear? And so MAC address table dynamic, it will show me only dynamic entry. If I will run here a static, it will show me only a static entry. And we have one more option like interface fast Ethernet 1/0/1. On this interface I want to check what is the MAC address. So you can see here, this is the MAC address of this interface, and this is the MAC address of router 1, because router 1 is connected with this interface. I can access router 1 also, just to show you MAC address PM123 and R1. Here I have router 1. You can check, so interface fast Ethernet 0/0 and include Y. You can see this is MAC address of router interface. In last it is 38, and here also you can see 38, same MAC address. So as you can see in the diagram, router 1 is connected with switch 1 with port 0/1. Because of that, router switch 1 have learned this MAC address on this interface, but it will flush this entry after 300 seconds or after 100 seconds, because this interface is in VLAN 10, and for VLAN 10 we have configured MAC aging time 100 seconds. Okay, and then if you want to, let's say, define manually this MAC address, I want that this MAC address switch should never flush the MAC address of router 1 from this interface, right? It should have one static entry, like always entry for this user, because let's say this is permanent user, or this switch is connected with one server, DHCP server, and this server is not going to change, right? I am not going to connect this server to any other interface or to any other switch. This is permanent device. These are laptop like user device, right? So these devices should, flexible. We can connect this device to any port, but server is fixed device. And let's say server MAC address is 0. Let's say server MAC address is A. So here, if server is permanent on this port, let's say 0/20, server is permanent on this port, then I will manually configure MAC address of server on this port. I will bind this MAC address on this port, right? Then switch is not going to flush it after MAC aging time. Let me show you that also, how you can do it. On switch, just you need to run this command. Is font size fine, or should I increase?
Fine, sir. Fine.
Please increase, sir.
Okay.
Because the
please increase.
Because the recording is in a low this format.
Okay.
Megapixels.
In next video I will increase it, okay, on the real device, and in GNS3 I think we have already increased font. So let me check there also. Before that, let me just run one command here. Okay, MAC address table and then static. Method is static. After that, what is the MAC address? So let me copy the MAC address of router 1. This is the MAC address here. I have copied this MAC address and let me paste the MAC address here. Okay, this MAC address. After that, it's asking for VLAN. For which VLAN? For, let's say, VLAN 10, and then on which interface? So interface fast Ethernet 1/0/1. Right now I have configured this MAC address statically, so MAC aging time will become infinity for this user. So MAC address table aging time, not aging time here, aging time also, aging time is fine, we discussed this. Static. So MAC address table static. Now you can see in a static we have one entry, this one. Okay, so for this MAC address, now MAC aging time will not work, because this is a static entry. MAC aging time is for dynamic entry only. Okay, and total number of how many MAC addresses are there? 21. Okay guys, and there is one term called SDM. SDM, you know, all SDM. SDM stands for switch database manager. It is used to change the memory on switch, because switch can perform layer 2 forwarding also and layer 3 forwarding also. So here, let's say sometime we need more memory for routing purpose and less memory for switching purpose. Sometime we need more memory for switching purpose, less memory for routing purpose. Sometime we need more space for VLAN purpose, right? So we can manipulate these things with the help of SDM. So SDM preferred. We can use this command to check the current SDM. Current SDM is this one, default templates. And in default templates you can see number of MAC address, how many switch can learn how many MAC address? 6000. And number of IPv4 address, how many IPv4 address? 1000, sorry, 8000. And multicasting, this is for multicasting 1000. IPv4 unicast routing 8000, means it can store 8000 root in their routing table, right? So for different purpose, you can see we have a space. But here we have option. Let's say we want to increase the space to learn MAC address. Like this switch should learn 12,000 MAC address in their MAC address table. That means I am going to use this switch only for switching purpose. Then why I will allocate this memory for routing, right? We are not going to use this switch as a router, so I will disable it. I will change the template. Then here you can see the difference is very simple. In packet tracer we are not able to see these all command. Okay, so MAC address table, and here in packet tracer we can run only these three command, not MAC aging time. These options are not available here. Maybe in GNS3 router, oh sorry, switch, or in EVNG switch you will have more option. Okay, now let's come here to this topology. First of all, in the same way, switch is going to learn MAC address of these all PCs. It will learn MAC address of PC 0 on which interface? On 0/1 interface. And if I will configure IP address here, let's say here you can see by default MAC address table is empty. Here there is no any entry. Now I am going to configure one IP address on this PC. Let's say IP address of this PC is 10.1.1.1 and 255.255.255.0, and gateway is, let's say, 10.1.1.100. That's it. Here I have configured the IP address, and let me check again MAC address table of this switch. Switch have learned MAC address automatically. Now tell me how switch have learned this MAC address, and why switch have learned this MAC address automatically. Because here I have not sent any packet, any data to switch. What is happening? How switch have learned the MAC address of PC 0? This is MAC address of PC 0. Here you can see the PC 0 MAC address. This is MAC address, same MAC address, right? PC 0 MAC address. Switch have learned this MAC address on 0/0 interface and in VLAN 1. Because of gracious ARP. You all know whenever we will configure the IP address, it will generate a gracious ARP. And on switch will receive gracious ARP on this interface. It will learn the MAC address. Right? Right, guys? In the same way, when I will configure IP address on PC 1 also, 10.1.1.2, subnet mask 255.255.255.0 and 10.1.1.100. Here also and here also, let me configure one IP address. 10.1.1.3, 255.255.255.0 and 10.1.1.100. I have configured the IP address on all three PC. That means switch should have entry for these all MAC address. You can see in the MAC address table, right? And type is dynamic, means there is MAC aging time. One timer is running for all these MAC addresses. Okay, so until and unless switch have these three MAC address, this PC can communicate with each other unicastly, right? But let's say switch don't have MAC address of PC2. So whenever switch will receive traffic for PC2 where destination is the MAC address of PC2, it will perform a non-unicast flooding. Is it clear? Recording is so important. Okay. Let's say, guys, this is my which server? Let's say FTP server. FTP uses which protocol at transport layer? TCP or UDP?
TCP.
TCP. Very good. Guys, FTP and TFTP both is used to upload or download file from the server, yes or no? From the file server. Both protocol is used for same purpose. Then what is the difference between FTP and TFTP?
For FTP, I think we have to share or download the only that small size files.
Okay, yes, very good. It is for large size, not a small size, and TFTP is for a
No, no,
small
no.
size.
Actually, I'm saying for the TFTP only. Sorry. Yeah.
TFTP, okay.
Yeah.
The see, first difference is FTP uses TCP and TFTP uses UDP. Okay. After that, port number of FTP is
21.
and 20.
21.
And TFTP?
I think 69. Huh?
Yeah, very good. 69. Okay. And here in FTP, authentication is required. Whenever you will upload something or you need to download something from FTP server, you have to provide username and password. But in case of TFTP, authentication is not required. Generally, we use TFTP to store iOS, means backup of, let's say, your operating system. It can be Windows operating system, or TFTP, or it can be Cisco IS like router configuration. And FTP is used to upload large size of file. Let's say uploading books, right? Large file, song, movie, those things. So what I can do, from PC number 1, I will create one file here on this PC. After that, I will upload that file on this FTP server. I will upload that file on FTP server, and I will show you how you can download that file from PC number 2. But before that, these machines need IP address, right? So what I want, that this server should act as a DHCP, and this DHCP server should provide IP address to this client machine. Okay. So first of all, on server we need to configure static IP address. So let's say FTP IP address is, FTP server IP address is 10.1.1.1, and TFTP server IP address is 10.1.1.2, and DNS server IP address is, let's say, 10.1.1.3, and this router, this interface IP address is 10.1.1. let's say 100, and this side here IP address is, let's say, 192.168.1.100, and 100, not 100, let's say 1. And these machine should get IP address from this subnet, in this subnet from DHCP server. So let me configure this IP address first, then we will move. On FTP server, first of all, let me assign IP address 10.1.1.1. Subnet mask is 255.255.255.0. Default gateway is 10.1.1.100. Okay. Then on TFTP server, here I am going to define IP 10.1.1.2. Subnet mask 255.255.255.0. Then 10.1.1.100. After that, finally DHCP server. So on DHCP server, let me configure 10.1.1.3, 255.255.255.0, and 10.1.1.100. Okay, I have configured the IP address on these 3 server. Finally, I need to configure IP address on router. So to configure IP address on router, you need to access router, go to CLI, and then no enable. And as you know, enable command is used to enter in privilege mode from the user mode. After that, from privilege mode to configure terminal mode, you need to run command config t or configure terminal. Then go to interface, fast ethernet 0/0. Then run first no shutdown command, because router interface is by default shutdown and switch interface is by default up. On switch you don't need to run no shut command, but on router you have to run no shut command. By default port is down. And then IP address 192.168.1.1, 255.255.255.0. okay, exit. Interface fast ethernet 0/1, here also no shut, and then IP address 10.1.1.100, 255.255.255.0. I have configured the IP address on both interface of router, right? And IP addresses on the server. Now if I will try to get IP address on this PC from DHCP server, will this PC get IP address, guys? Can this PC get IP address from DHCP server?
No,
Why?
because both are into different networks, and in the L3 that IP helper address has to be configured for DHCP IP.
Otherwise router will drop the discover message. If we will not configure the IP helper address here, router will drop the discover message. As I told you that in DHCP we have 4 messages: discover, offer, then request, and then acknowledgement. So first, when client need IP address from DHCP server, it will generate discover message, and discover message is broadcast. Let me show you first the discover message. Here I am going to use simulation mode, and now I am going to generate one discover message. So to generate discover message, here I am going to click on DHCP. See, this is discover message, right? PC have generated one discover message. Let me open this discover message. Okay. Okay, if you will check the information inside this discover message, is it visible? Is it visible?
Okay, sir.
Yeah.
Yes.
So you can see here, this is the DHCP discover message. We are not going to discuss about this. Inside the discover message also, if you will see client IP address, because client don't have any IP address, so client IP address is 0.0.0.0. Okay, your client address is 0.0.0, server address is 0.0.0. These informations are there. Then as you know, DHCP uses UDP, so here is UDP header. Inside the UDP header there is source port and destination port. So DHCP uses 2 port, 67 and 68. 67 is used for server, used by server, and 68 is used by client. It is for client. So here client is sending message to DHCP server. So source port will be what? 68, which is used by client port number, and destination port will be what? 67. So source port is 68, destination port is 67. 67 is for DHCP server and 68 is for DHCP client. Okay, so inside the UDP header we are able to see only these two important information: source port and destination port. Then this is IP header. Inside the IP header you can see source IP address is 0.0.0.0, destination IP address is broadcast 255.255.255.255 broadcast. And then at layer 2, this is Ethernet header. At layer 2 also you can see source MAC address is the MAC address of PC0, and destination MAC is broadcast. So it is broadcast message at layer 2 also, at layer 3 also. And as you know, router divide broadcast domain, means router have this time in this topology how many broadcast domain we have? 2 broadcast domain, right? One is this one and one is this one. Router divide broadcast domain. So router will simply drop this broadcast message. Okay, so actually I need to tell to router that whenever you will receive discover message, that is broadcast, you should forward that message to this DHCP server. Okay, so I need to run one command here, that is DHCP helper address, because if I will not run DHCP helper address, you can see what will happen. It will forward this packet to switch. Switch will do broadcast because it is broadcast message. At layer 2, switch will first learn the MAC address of PC0 on 0/1 interface. After that it will check destination field. Destination MAC is all F, so it will forward one copy of this frame from its all interface except receiving interface, means except fast Ethernet 0/0, it will forward this broadcast message from all its interface like this, right? And see, all devices have drop it. So router is not forwarding discover message to DHCP server. That's why Here you can see this PC is not able to get IP address. Getting my point? Right? PC have got one IP address from DHCP, Apipa. Apipa is like chocolate. If baby is crying, then you can, give one chocolate to keep him silent. Like this, if machines are, generating discover message to get IP address, and machine are not able to get IP address from DHCP server, it will again send DHCP discover message. Because of that, we have one concept that is called Apipa. Apipa will provide one automatic IP address to machine for the temporary use. Now this machine have identity, it can forward some data. Earlier this machine was not any IP address, but this machine have one IP address, and Apipa will always provide IP address from this range 169. This is reserved for Apipa. This is temporary IP address. Okay, now I am going to configure IP helper address on this router. See, on fast Ethernet 0/0, on fast Ethernet 0/0, which is connected to LAN network, I am going to say IP helper address, and then IP address of DHCP server. So IP address of DHCP server is 10.1.1.3, 10.1.1.3. That's it. And now if this client machine will generate discover message, let me show you what will happen this time. Now when this client machine will generate discover message, here discover message, again you can see source IP is 0.0.0, destination IP is 255.255.255.255. Source MAC is the MAC address of PC 0, and destination MAC is broadcast. Now again switch will receive this broadcast frame, it will forward one copy from all interface, and this time you can say router is forwarding one unicast message to this DHCP server. First of all, it will generate one ARP message, as you know, because router 1 don't know what is the MAC address of 10.1.1.3. On router you can verify that also. So IP ARP, in ARP table you can see there is no entry for which IP address, for 10.1.1.3. it have already entry for 10.1.1.3 in MAC address table, so it should not generate ARP message. But okay, this is packet tracer, anything device can do anything. Okay, and this time DHCP server will generate what? ARP reply message. It will forward ARP reply message to router, and then here we are not able to see the packet correctly. Now client is getting IP address. Yes, this time also client is getting IP address from Apipa, not from DHCP server. So what is the problem now? Now problem is we have not enabled DHCP services here, or we have not configured the pool. So let me take you to DHCP server, and now I am going to configure one pool here. By default DHCP service is off. Let me turn it on, and pool name is CCNA, and then default gateway IP address 192.168.1.1. you can see for the user, for computers, default gateway is 192.168.1.1. okay, and then DNS server IP address, let's say anything 8.8.8.8, and a starting IP address 192.168.1. let's say 2, because I have used one IP address, and rest thing is okay, not important. Now again let me try to get IP address. Yes, this time this PC is getting which IP address? 192.168.1.2. Guys, I am going to show you all message like discover message, discover, offer, request, and acknowledgement in GNS3. I will capture the link and I will show you these all messages. But in packet tracer, here this is window operating system. So in case of window operating system, let me generate again one discover message. Oh, This is discover message, right? Now you can see router is forwarding this discover message to DHCP server, and when DHCP server will receive this discover message, it will generate offer message, right? Offer message. This is ICMP message. What message it is showing? So it is better to capture these 4 packets in GNS3, I think. This is ICMP message. Client will generate one offer message, okay, and that will be also broadcast. I will show you it in GNS3 by capturing the link. After that, I have some configuration on this router, right? I want to save this configuration, or I want to take backup of this configuration on this TFTP server. So what I need to do, first I need to enable TFTP service here, TFTP, and by default TFTP service is enabled, and these are the file. See, on this router I can run on one command, copy, as yesterday also we discussed this, copy running configuration to, and let me configure something here like host name is, let's say, CCNA, right? And we have IP configuration, and we have IP helper configuration. Then let's say enable password is Cisco 123. Okay, so these are the configuration on this router. Now I am going to save this configuration first, and then copy running configuration to startup configuration. Sorry, it's not a startup, TFTP server. Then it will ask for IP address of TFTP server 10.1.1.2, then file name. So by default file name is CCNA config. So if you want to replace the name, you can write down the name here. Let's say name of my file should be CCNA. Okay, and now it's storing 680 byte information to TFTP server. Now on TFTP server also you can check there is one file with name CCNA, here it is, right? Now if I will delete the configuration of this router, now these PC are getting IP address from server. Yes, all PC are getting IP address from server. You can see PC1 have also got one IP address, that is 192.160.1.3, and PC2 can also take one IP address 192.168.1.4. okay, now I am going to erase startup configuration of this router. I have deleted the startup configuration, and then I am going to reload the router. So running configuration will also get lost. Now on router we will not have the configuration. So what we can do, two options: either I can configure everything again like host name, IP helper address, or I can configure only one IP address on fast Ethernet 0/1, so for the reachability between router and TFTP server, and then I can copy my entire configuration from TFTP. Okay, so here say no, and you can see now by default router name is router, but in configuration router host name was CCNA. So simply I can configure one IP address on fast Ethernet 0/1, interface fast Ethernet 0/1, say no shutdown, and then IP address 10.1.1.100 and 255.255.255.0, right? So now I can ping TFTP server, ping 10.1.1.2. 2 is the IP address of TFTP server, right? Yes, 2. So ping this server. Let me check the connectivity. Yes, I am able to ping. Now I can copy what? Copy from TFTP to running, or you can copy it in a startup also. A startup or running, doesn't matter where you want to configure. Okay, then it's asking for the IP address of TFTP server 10.1.1.2, and then it's asking for source file name. So when you will copy it, what should be the name of your file? Let's say again CCNA, and destination file name. What is the file name on server? CCNA, right? Here by default configuration name will be this one. Source file name means the file name on server, and the destination file name means the file name on router. When you will copy the configuration, running configuration, what should be the file name? So okay, let's say file name is default running configuration. This should be the file name on my router. Okay, or if you want to change the file name, you can change it. That's it. Now here you can see host name is changed, CCNA. Earlier host name was router. That means I have restored the configuration from TFTP to this router, and then again I will save the configuration. So this is a small practical of TFTP. This is not much important, but okay, we can perform the practical also like in packet tracer. Then this is problem of packet tracer, guys. This interface fast ethernet 0/0 should be no shut, because in the configuration I have run no shut command on this interface, but when I have copied the restored the configuration from TFTP server, I lost no shut command from this interface. Here I can check the running configuration, so run to check the command on this interface. Like on fast ethernet 0/0, you can see no shut command is not there, shutdown command is there, that is by default. Okay, so here I need to run no shut only, rest configuration is fine. And this is problem of packet tracer interface fast ethernet 0/0, say no shutdown, that's it, fine. Okay, and again now this user can get IP address from DHCP server. Now let me configure FTP server, file transfer protocol. So again in services section we have FTP option. FTP, where it is, FTP. By default this service is on, and as you know, by default username is Cisco and password is Cisco. If you want to add more user, here you can create more user, right? And you can give the permission accordingly. Like I am going to create one more user here whose name should be CCNA, username is CCNA, and password is also CCNA, right? And here I am going to give permission, right? Delete, not delete, and not rename. Okay, like this, add. Okay, so this user have write access, read access, delete access, right? Not delete access, write access and read access only. Okay, now on this PC let me create one file, a small file. Here text editor, and you can write something here, hello, anything, right? And then I can save the file. Then it will ask for file name, so let's say file name is ccna.txt, as I told you yesterday also. Okay, now if I will check directory of this computer, we can see it in the directory there is one file, this file ccna.txt. I am going to upload this file on FTP server. So first requirement is reachability. There should be reachability, ping 10.1.1.1. Now doesn't matter where your FTP server is, right, located, maybe in data center, in different location, in different country, but if there is reachability, you can upload the file, you can download the file. So here I am going to check the reachability first. Because of R, first packet will drop, but from second packet you can see I am getting reply message. That means there is reachability between my PC and FTP server. Now to access FTP server, you will run command FTP and then IP address of FTP server 10.1.1.1, and username is CCNA, password is also CCNA, right? Now I am going to say put. To upload something on FTP server, you will run command put and then file name. File name was ccna.txt, right? Here on TFTP server, now we can see one file ccna.txt. Okay, and here I am in TFTP, I have access of this FTP server, so I can also check directory of this FTP server here. So in directory also you can see we have one file ccna.txt. Now PC2 want to or PC1 want to download this file. So how PC1 will download it? Again PC1 need reachability. First of all there should be reachability. So let me check the reachability. Ping 10.1.1.1. Yes, there is reachability. That means I can access the FTP server if I know the username and password. FTP and 10.1.1.1 and username ccna, password ccna. Now to download something from FTP server to your computer, you will run command get and then name file name. File name is ccna.txt. That's it. So here you can see on this computer we have copied it. Okay. Now by pressing Ctrl+C, I am in PC CMD and here I can check the directory. In the directory, yes, I have downloaded this file. So this is a small lab of FTP, TFTP and DNS3. Sorry, DHCP. DHCP lab is still pending because we have not discussed the 4 types of packet. So I am going to configure DHCP on router and I will capture the link. Here let me design one topology in GNS3 R1 R2. Let's say this machine is DHCP client. This is DHCP client, or this is client machine, and this is server. This is server machine. Server. Okay. Now let me connect the device. And let me configure the scenario first. Font size is small, right? Let me increase the font size. Is it okay now?
Okay, sir, this is fine.
No. Wait. Sorry. Okay, thank you. IP address is 10.1.1.1 255.255.255.0. I've configured the IP address here. On server also interface fast Ethernet 0/0 no set and IP address 10.1.1.2 255.255.255.0. Okay, I have configured the IP address on both devices. You can check the connectivity. How? First of all, on client machine I am going to run one more command, no IP routing command to disable routing feature, because this router is my client. I am going to use this router as a client. So here IP address is fine. Here I have disabled the routing. Right now I am going to check that I am able to ping server 10.1.1.2. Yes, I am able to ping the server. On DHCP server, here I am going to create one pool, IP DHCP pool. This is how we will configure DHCP service on router. IP DHCP pool, and then pool name is, let's say, CCNA, and then here we will define the network 10.1.1.0 mask 255.255.255.0, right? Means from which network this DHCP server is going to provide IP address, right? From this network. Then what should be the default gateway? Default router, let's say default gateway should be 10.1.1.2 anything, right? After that, what should be the DNS server IP address? If you have DNS also, you can configure DNS server, let's say 8.8.8.8. okay, so this is the all configuration, guys. This is how we can configure DHCP on router. Configuration is done. Now if this client machine need IP address, see interface fast ethernet 0/0, I'm going to say no IP address, right? Now you can verify, do so IP interface brief. We don't have any IP address on fast ethernet 0/0 because I have removed the configuration. Done. And this time I am going to say to this interface IP address DHCP, please ask for IP address to DHCP server. And now let me check. So IP interface brief, I have got any IP address? No, I have not got any IP address from DHCP server. But now you can see the message. Fast Ethernet 0/0 have assigned this IP address 10.1.1.1. Who have provided this IP address to this machine? DHCP server. Now how? Let me again say no IP address DHCP, no IP address interface fast ethernet 0/0, no IP address DHCP, right? Okay, now again if you will check IP configuration, so you can see this router client machine don't have IP address. Now this time I am going to capture the link. Okay, let me start the capturing here. Okay, this is the capturing, and from client machine 1 I am going to again run this same command, interface fast ethernet 0/0 IP address DHCP, IP address DHCP. So first it have discover the DHCP server with the help of which message? Discover message. This is DHCP discover message, this is offer message, this is request message, this is acknowledgement message. Okay, so we can see these all messages are broadcast. These all message destination IP address is broadcast. Yes or no?
Yes,
At
yes.
layer 3, yeah, right? DHCP. I want to see only DHCP message. Okay, so if I will open DHCP discover message, so inside the DHCP discover message you can see this is actual DHCP discover message. In the UDP, source port is 68, destination port is 67, source IP is 0.0.0, destination IP is 255.255.255, source IP is the IP address of client machine, destination source MAC is the MAC address of client machine, and destination MAC is broadcast. Then in the offer message, source IP is, first of all, source port is 67 because DHCP server is forwarding this message, generating this message. So source port is 67, destination port is 68, means server to client. This is server to client message. And then inside the IP header, source IP is the IP address of DHCP server 10.1.1.2, destination is broadcast. Because DHCP server don't know IP address of client machine because client machine have not got any IP address till now. But here at layer 2 it can do unicast, but don't know this message is why broadcast at layer 2, because now DHCP server know what is the MAC address of client machine, because in the discover message source MAC was the MAC address of client machine. So this message should be unicast at layer 2, but again it is broadcast at layer 2 also. Okay, then request message, and if you will open offer message, you can see inside this offer message it is offering IP address. Your IP address is 10.1.1.3, and I am 100% sure this machine is going to use this IP address 10.1.1.3. So DORA process is done. Here on client machine we can check so IP interface brief. So yes, this machine have got this IP address 10.1.1.3. So server have generated one offer message, send one offer message. In offer message they have sent one IP address, and offer message and discover message both are broadcast at layer 2 also, at layer 3 also. Let me open request message. Again client machine will send request message, and it is requesting for this IP address 10.1.1.3. request IP address 10.1.1.3, right? And DHCP, okay, these are the field inside the DHCP message, request message. But important is source port, destination port, source MAC, destination MAC. Source MAC is again what? 0.0.0. So interviewer can ask you what will be the source MAC inside the request message. So request message will have 0.0.0 source address, and destination is again broadcast, right? But again client can send this message as unicast because client know the IP address of DHCP server, but this is broadcast message. And at layer 2 also you can see broadcast. Source MAC is the MAC address of client machine, destination MAC is the MAC address of server. Okay. And then finally acknowledgement message. Acknowledgement message is also broadcast at both layer 2, layer 3. Okay. So now hope it is clear to you how DHCP works, how DHCP gets IP address from the server, how many messages are there, and why these messages are broadcast at layer 2, and how first which client will generate which message, server will generate which message. First of all, which message will be generated by client, right? Why offer message, why request message, why acknowledgement message. So these are the small concept interviewer can ask you to check your knowledge. Is it okay?
Okay, sir.
Great. What will happen here if I will, let's say I am attacker. I am going to attack this network, this user. I am going to attack this user. So how I can attack? What I can do? I can connect my computer here, or I can connect one DHCP server here. DHCP, I can either connect DHCP server, or I can run an application on my computer and I can create the pool. I can use my computer as a DHCP server as well, right? Only configuration is required. You need to install the application. So let's say this is rogue DHCP server. This is rogue DHCP server. This is attacker. Attacker is going to provide different IP address. Let's say this server, they have connect their server to switch. And now whenever these machine will try to get IP address from DHCP server, this attacker will also generate discover message. And if these machine or any machine, let's say PC1 have generate one discover message, right? Discover message is broadcast. Attacker will also receive discover message, and my actual DHCP server will also receive DHCP discover message, right? And client will send offer message to that DHCP server who send offer message first, right? Next message that client is going to send is request message. After discover message, it will receive the offer message. Let's say both machine, this machine also and this machine also have generate the offer message. So machine have, let's say, receive offer message from this attacker first, and then it have received the offer message from this server. So this client machine is not going to send the request message to this server now. It will send the request message to only one server from whom it will receive the offer message first. So this time which DHCP server is closer? This actual DHCP server or rogue DHCP server? Rogue DHCP server. So these machine will get IP address.
Sir, is there any predefined time?
Yeah.
Any predefined time or time for waiting? Like
no. Let's say you are asking for an IP address, and two people are providing you IP address to whom you will accept.
like what is the sir? What is the guarantee that my request or my response reach to them faster than the original DHCP server?
So that's why on switch now we will configure it. We will configure this port is untrusted port. Don't trust on this port. This is also configuration of DHCP. That's why I want to finish
Okay,
it
okay,
here.
okay.
Okay, so let me do one thing. On this server also, I am going to enable DHCP service. Let me first configure one IP address. This is 172.16.1.1 and 255.255.255.0, let's say. And default gateway is, let's say, 172.16.172 dot, sorry, 16.1.1, and DNS server IP address is, let's say, 1.1.1. Everything is different on this DHCP server, and here in DHCP I can create one pool name is, let's say, CCNP, and here router gateway IP address is 172.16.1.1, and DNS server IP address is, I am going to provide 1.1.1, and I am going to provide IP address from this range 172.16.1. let's say 5, and subnet mask is this one, rest thing is same. Okay, now let me try to get IP address again on this PC. Let me check this PC is getting IP address from which server first. From which server it is getting IP address, guys? From the rogue server, yes or no? Why? Because rogue server is closer. So definitely it will get offer message first from the attacker. Now if PC want to access internet, okay, this PC can access internet, but it will access internet through this attacker. So attacker can capture the link, it can read your data, right? It is going to their next hop. Now, sorry, default gateway of this PC is 172.16. Default gateway is not configured, but attacker can provide default gateway also. So whenever, let's say, this PC is going to communicate with their data data center in different location, so yes, they can communicate with their data center, but through attacker default gateway, not from their actual default gateway. Actual default gateway is this router, right? And this PC is going to forward traffic via attacker. So this type of attack is possible in network. Because of that, we have one concept in DHCP called DHCP snooping. DHCP snooping. So to secure it, what we can do on switch, we can configure trusted port and untrusted port. I can tell to switch only this port is trusted port. Don't trust on any other port, right? By default, if you will check this switch configuration, like here, if you will run command, what is the command? So IP DHCP snooping. So there is no any trusted port. If there is no trusted port, that means all port is trusted. So manually I can tell to this switch that, brother, your 0/4 interface is trusted. For that, first of all, you have to enable this feature on switch. You need to run one command, IP DHCP snooping trust on interface, and IP DHCP snooping. One is this command, another one is IP DHCP snooping for which VLAN, for, let's say, VLAN 1. By default, all interface belongs to VLAN 1. For different VLAN also we can do it. After that, interface fast Ethernet 0/4, and to this port I am going to say IP DHCP snooping trust, right? So this command will enable DHCP snooping service on this router. This command will define DHCP snooping for which VLAN, and this is the command to define trusted port. Okay, hit enter, and now I am going to check. So the IP DHCP snooping, and this time you can see fast Ethernet 0/4 is trusted. Now this time trusted port, yes. Okay, and now let me again try to get IP address to from DHCP server on this PC. This time let me check this server is getting IP address from which server? Actual server or rogue server? Actual server. 192.168.1.6 is the IP address. That means this is this PC is getting IP address from the actual DHCP server.
So, Praful, you mentioned that by default all ports and switch are trusted or untrusted?
Untrusted. If there is no trusted port, means all ports are trusted. If you have, let's say, not configure any port as a trusted, so by default all ports are then trusted, means snooping is not working. Okay, can I move to next protocol? Next protocol is last protocol, let's say telnet and SSH. So on this server I am going to, let's say, configure telnet. So command to configure telnet is line VTY 04 and password is, or not 04, you can configure 0 only, line VTY 0, and then I am going to say password is Cisco 123. On line VTY 0 I have set this password, and then I am going to say login local. See here I have command to configure login local. If I will configure login only, what will happen? Let me try to access this server from client machine. Oh, I have enabled this on client machine. Say no line VTY 024. Can't delete last 5 VTY line. Okay, so run line VTY 0, password is this one. Line VTY 0, no password. Okay, let me configure this command on this server, on this router, server router, line VTY 0. I'm going to say password is Cisco 123 and login. When I will telnet this server, first let me run this command telnet and 10.1.1.2. This is the IP address of server. Okay, it's asking what password. Password is Cisco 123. So now you can see I have access of server router. Server router, I can configure anything here. But enable password is not set, because of that we cannot enter in privilege mode. And in the capturing, also you can see, before sending the telnet traffic, it have first establish a connection, yes or no, TCP connection, three-way handshake, right? One machine will use what port number? Which machine will use port number 23? Server. Port number of telnet is 23. Okay, so here it have just asked password, but if I will say login and then local, now what will happen? Here I am going to again access this router through telnet. It's asking username. What is username? What is username? Username, here we can configure the username on this router. Username CCNA, and again let's say password is CCNA. This is different password. Now on the client machine I am going to say CCNA. It is asking for password CCNA. Username CCNA. Password was CCNA or something else?
CCNP.
CCNP. Yes. So when I am running login command only, it will ask for password only. Login local means username and password. And here on this server or client on any machine, if you want to check TCP connection, TCP establishment, so you can run command show TCP brief. This is command to check TCP table, transmission control block. TCP table is like three-way connection. Okay, so by running this command we can check, yes, there is one TCP connection between 10.1.1.2 and 10.1.1.3, and 10.1.1.2 is your server router, it is using port number 23, and this is your client router, it is using random port number, and state is established. Is it okay? In the telnet, if you will open any telnet message, you can see the information. This is telnet, actual data of telnet. Then a transport layer, again source port, destination port. So source port is random port number, means client have sent this client telnet request message. Destination is 23, sequence number, acknowledgement number, source IP, destination IP. So in this scenario, in telnet, all messages are going to send on unicast address, not broadcast. At layer 2 also, at layer 3 also, it is unicast. And see, when I run exit command, so it have closed the connection with this message. In the same way, we can configure like which service, SSH on this server. We can configure other application layer protocol. Hope now application layer protocol is clear, and now we can move to routing module, because now we don't have anything in basic. I covered everything, like here in this file you have already command, but by the way I have performed lab of all. Static routing is there directly, and in this folder let me check anything left. Subnetting IPv4. Okay, application layer protocol, segmentation, fragmentation, IP header, UDP header, TCP header, TCP IP protocol, encapsulation, decapsulation, transport, data link layer, network layer, and TCP, reliable, unreliable, sequencing, three-way handshake, connection oriented, connectionless, port number, application layer, OSI model, how to break password. Basic command, these are if anyone don't know how to configure IP address or these things. How to configure banner, modes of router, booting behavior, content of router, memory, IP addressing, subnetting, how switch works, how switch learn MAC address table, broadcast domain, collision domain, networking device like router, switch, mode of communication, type of network, advantage, networking. Yes, in basic module I think I have covered everything. We don't have any topic in basic module. Now we should move to routing module. Okay.